Well, this is a episode of Basic Electric Principles. In the interest of time, I've already drawn out the circuit analysis. I gave this particular circuit here and asked, what is the current? What is the total current, or I sub T? And it's a 12-volt source, voltage source. It's V sub C, V sub S, I'm sorry, 12-volt voltage source. So that means you have to figure out what the equivalent resistance is from this point to this point. And once you figure out the equivalent resistance, it's just a matter of dividing this voltage by that equivalent resistance to get the current. But the problem is you have to go through all of this to find out what the equivalent resistance is. So anyway, let's get started here. One thing you can notice is if you look at this, just from here this way, isn't this just some resistance? We don't know what it is from this point to this point, and it's in series with this resistor and this resistor. Or you could think of it this way: the current is flowing out of this voltage source is the same current that's returning to this voltage source. So therefore, these two resistors are in series. In other words, 60 ohms. 30 plus 30, because they're in series resistance, 60 ohms. So this is the way I've wrote it. R sub 1 dash 7. That's how I'm going to do it. That means resistor 1 and resistor 7. In other words, these two resistors added together give you this resistance, which is this resistance here. R1 plus R7. 30 plus 30 is 60. So that's how we get this resistance. Look here. We have a series resistance here. 30 and 30 is 60. So we get 60. So R sub 2, 4, resistances 2 and 4 added together. That is, the 30 plus the 30 is 60. So that's how we get this. Same thing here. We get 140 and 100, which is 240. So R sub 6 and 8 added together gives you the 240. So now we've reduced this circuit to something that's a lot easier to work on. From here, you can look at this as a Y to delta conversion to make it even easier, or T to delta, whatever, but just with a little perceptiveness, you can see that 30 over 20 is the same as 60 over 240. Why does that matter? Because this resistor, there's no current flowing through it. So it's irrelevant to the circuit. It's there, but it's irrelevant because the voltage on this side and the voltage on this side are going to be exactly the same, so no current's going to flow through here. So you can act like as if this resistor doesn't even exist. Just take it out. Or you can go ahead and do the, Y to delta conversion. It's still going to come out and work the same way. So let's move this up a little. So what we get is, taking this out, what we get is Just a simple matter of adding these two together to get 150, and adding these two together to get 300, and these two are in parallel, which is what I'm saying here. This is in parallel with this. So these two resistors in parallel end up being 100 ohms. You already got it in series with 60 ohms. So we get a total equivalent resistance of 160 ohms. So 12 divided by the equivalent resistance of 160 ohms give us 0.075 amps or 75 milliamps. Hope this helps. By the way, you could come to my lives and we could learn stuff like this or work things like this out on my lives. I'm on all the time. Just shoot me a note or something, and I'll make an event and we'll go live.